C. Lindelof videos, AP Calculus. I found that I'm doing a ton of these videos right now because I found that 95% of the AP exams, the AP Calc exams in the last 10 years have had a question like this on it. So I figured I'd throw a bunch of them out there. So here's one. This is off the 2002 AP exam. It says that a particle moves along the x-axis so that its velocity v at any time for t is greater than or equal to 0 and less than or equal to 16 is given by v of t is equal to e to the 2 sine of t minus 1. At time t equals 0, the particle is at the origin. So what I'm going to do is some stuff here. So I'm just going to say, okay, I'm going to need this later. I'm going to need to remind myself of that later. And then I'm going to start moving on to this. On the x-axis provided, sketch the graph. So this is what I did. I just want to be completely plain about this. This is the calculator section of the exam. So I'm going to use the calculator. So this is what I did. I went and I just graphed this on my ti-nspire CAS calculator. Came out looking like this. One thing I did do was that I went to the menu section and I went to Zoom, I went to window settings, and look, I set the settings exactly the way they had them, and that's how I did that. So I get the graph back that they got. So I can't look at both of these things with you simultaneously, so I'm going to go back and forth. So I'm going to take this graph, right? So this would be on your calculator, and you're looking over at the page, and that page would look like this one, wouldn't it? It would look like this. And I'm just going to start to graph this thing and say, it looks like this. It had this thing somewhere between 0 and 4. It had a high point that was just a little bit less than 8, and it came up out of the origin. It came up like this. Somewhere before 4, it went back down. Somewhere before 8, it goes back up. I'm going to try to put this a little bit to scale because there's some pretty obvious stuff going on here. I want to make sure we can see it. So it's down like that. And then between 8 and 12, it does the same thing again, right? It goes up to the same height again. It comes down, right? Does this thing. Somewhere just past 12, it goes back up, right? Somewhere around 16, does that. I'm going to go back and look at my thing. If I was able to, I'd be doing this on I'd be looking at them both at the same time, but I'm not able to. I can see here that this thing, there is some space here, someplace before, someplace before 16, it goes back under. So that's important to know. So that's what my graph looks like. So that's part A. Part B says, during what intervals of time is the particle moving to the left? Give the reason for you. Well, what I know is this. When is it moving to the left? So for part B, when is it moving to the left? I know it's moving to the left between here and here, right? How do I know? Well, this is the velocity function. And if your particle is moving horizontally, then left is, negative is left and positive is right. So all this here is positive velocity. That's going to the right. Everything down here is going to the left. So all I need to do is find some stuff out using my calculator. So I'm going to go to menu, analyze graph. I'm going to find the 0. There's one here, right? 3.14. Hopefully you recognize that's pi. And then let's go to here. And I'm going to do the same thing again. Analyze graph. 0. Ask me for a lower bound, upper bound. Ask you for a point to the left of the point you're looking for. Ask you for a point to the right. So I'm hoping that you can, whoops, I should have done this one here, sorry. That's all right, they're all the same. Let me go back and look at this real quick, though. You have to do them all anyway. 0. I'm looking for this one right here. In here. Hopefully you can see this. This is 0 to 3.14, 3.14 to 6.28. So hopefully you can see this is pi to 2 pi, and hopefully you can tell this is the distance in between because it goes from pi to 9.24, and I'm hoping that you can see that this is 3 pi. I'm hoping that you can see that that's 3 pi. And let's look at the next one. Exactly the same thing. Analyze the graph. Find the 0 here to here. Hopefully you can see that this is supposed to be 4 pi, right? And hopefully you can see over here. So this would be 5 pi right here, wouldn't it? So let's look at that really quick. I'm going to do this last one. Analyze graph. 0 here, and believe it or not there. You can just move this thing down here. So it's 15.7. Hopefully you can tell that that's 5 pi, and you should just be able to see what you should recognize is this pattern. 3.14 is pi, 6.28 is about 2 pi, right? And the distance between here and here is pi. This thing is symmetrical, so the distance between here and here is the same, hopefully. So that's what I'm getting to. So what I want to say is, where are those areas? Well, from pi to 2 pi, and then from 3 pi to 4 pi, and then from 5 pi to 16. So I'm going to go back now with the information that we have. All right, I'm going to go back with the information that we have, and I'm going to start filling this thing in. So this is question B. So I'm going to write here, right here, B. Right, part A was the graph, so make this a little bit bigger. B was is this, so on what intervals is it? And we looked at that carefully, and we found that it's between pi and 2 pi. We looked at the next interval where the function has heights less than 0, and that was 3 pi to 4 pi. And then from 5 pi to 16. All right, and that's all they're looking for. That's our intervals where the particle's moving left. Our intervals where particle moves left. Okay? So there's that. Done with it. So we go on to part C, right? Go on to part C. So C, of course, was back a page, so go back and look at this. Part C says, find the total distance traveled by the particle from 0 to 4. We have to be a little bit careful here, right? 0 to 4. Right? It says 0 to 4. It does not say 0 to 16, so it's kind of a trick there. So this is really easy because this is a calculator section, so this is what they're anticipating you doing, that you say that the distance is equal to the definite integral from 0 to 4, right, of the absolute value, right, of e to the 2 sine t minus 1, right? And all they put in here actually was v of t was their answer, but this is fine. So this is the calculus that they're asking you to show. If you just put in the answer, which happens to be about, what is it? I'm going to put this in. About 10.542. Right? 10.5.2. If you only put this in, you're going to get less than 1/2 of your points. So they want all of this. And this is our distance. All right? That gets us to part D. That gets us to part D. We go back and look again. Part D. Part D. And part D is this. Part D says, is there any time when the particle returns to the origin? Well, you got to start with this idea, and that's what I grabbed this for up here. It said, okay, we know that this thing is, at time is 0, the particle is at the origin. This is not the position function, it's the velocity function, but I just want you to know it here. We started here. And then look, it goes right. How far does it go right? This whole area here, it goes right. Right? When does it go left? This whole area here, it goes left. When does it go right again? Here. Then how far back does it go left? Just this little bit. Then how far back to the right does it go? So from at the beginning, it's at 0. It moves this whole area here to the right and then only moves back this much. So the answer is no, it does not. Now, describing why that's true is a little bit more challenging, but no, right? The distance traveled right is always greater than, I'd say corresponding distance left. So no. And then you know what? If I'd write here C graph. I really would. I put here C graph. I might even write please see the graph. Because if we look at the graph, look, you could say this. What you can see if you're trying to demonstrate your point is t equals 0 particle at 0, 0, right here. And then you can say distance right. And you can see the distance right here is greater than the distance left. Distance right greater than the distance left. Distance right greater than the distance left. There's this little place in there, right? Okay, so those are my answers. That's how I would do this. I would make sure that I use my calculator as much as possible. And remember, they're looking for your calculus notation. They're looking for the notation of your calculus. So make sure that you're writing good calculus and using your calculator to only provide the answers. Again, I'm going to say it one more time because it's really important. Your answers out of 9 points here, your answers, your numerical value answers, are worth like 2 out of the 9 points possible here. So let's hopefully make sure that we get that. Hopefully this was really helpful to you. I really appreciate you watching the videos. If you haven't already subscribed, please do. I appreciate it.